Today we're going to be talking about an idea called composition of functions. Our notation for this is going to look like this. We'll have one letter and then a parentheses right away with no x. So we learned earlier this year that our function notation, we can read like f of x. That the parentheses say the word of. To read this, we would say f of g of x. We don't say anything for the closed parentheses because it would be weird to say like of at the end of something. So, but we would read this f of g of x. The parentheses we say is the word of. And what we're doing is we're going to be working with two functions like we did yesterday, but we're going to be taking one function and plugging it inside of a second function. Okay, so we'll be looking for an inside function and an outside function. There are other notations that also mean composition. The most popular one is to write kind of an O. I don't like this notation personally, just because I think by writing the parentheses, it's easier to see an inside and an outside. So I like that because that's what composition really is. And our book uses the notation that I like, so that's a good thing. Other textbooks sometimes use that other notation. Yeah. We will again today be considering domain. So I guess the good news of that, no matter how you look at it, if you're a glass half full kind of person, is if you got it yesterday, good, you get to do it more. And if you didn't get it yesterday, then we get to practice more. So then we can have more practice before we roll around to the test on this stuff next week. So we will be considering domain again. For our composition, we care about the domain of the original inside function and of the final answer. So yesterday when we were doing our arithmetic, we cared about the domain of each original and the final answer. For composition, we only care about the inside original and the final answer. All right, so I'm going to color code my problems as I do the notes to kind of help you see what exactly is happening here. If you find that helpful, you can do it in your notes. If not, that's fine. Doesn't really matter. It's just a way that I try to make it a little bit more clear what we're talking about with inside and outside. So this f function, and my f is going to be in this problem our outside function. Then I have the g function. In this problem, g is the inside function. So to do a composition of functions, what you are going to do is write out the entire outside function except wherever the x is, just put a big open set of parentheses. So I'm going to rewrite that f function, which is 3 something to the negative 1. So instead of writing the x, I'm just going to leave a big blank. In that blank, we are going to put the inside function. Okay, so to do a composition, you write your outside function, except instead of writing the x, just leave a big blank and put parentheses there, and then in those parentheses in that blank, put the inside function. Okay, so that's the composition. Then we just need to clean this thing up a little bit by simplifying. What does a negative exponent do? Makes it into a fraction. And only the stuff in the parentheses has that negative exponent. So the 3 is going to stay on the top, but the stuff in those parentheses is going to go down to the bottom. Yeah?
Do you do the parentheses first?
We can't distribute a power to pluses and minuses. If that was a multiplication, like if it was 2x times something, then we can give that power to everything inside, but otherwise.
Or can't you do the 3 times 2x?
Oh, no, we can't distribute. Order of operations, we have to do exponents before we multiply. So that'll be our final answer, and then we need our domain. For domain, we care about the domain of the original inside. So the inside in this problem was g. So we're going to look at g in our questions that we asked yesterday. First, is there any division? So in g, is there any division? No. Are there any even roots?
Nope.
No. So then our domain of g would be all real numbers. G doesn't have any problems. Then we want to consider the domain of our final answer. So in our final answer, is there any division?
Yes.
Yes. What would make us divide by 0? Or how would we find that?
2x minus 1.
Okay, so if 2x minus 1 equals 0, we have a problem. Because the bottom of the fraction is not allowed to be 0. So then we're going to solve this problem out. Add 1 to both sides. So 2x is 1, and x is a half is a problem, so that means x can't be a half. Because we don't want to have problems. Are there any even roots in here? No. So then our domain only has one single restriction. X could be anything in the world except for 1/2.
So
Every other number is fair game. 1/2 is not allowed.
Could you go over or why you did the 2x minus 1 equals 0?
Yep. So yesterday our 2 questions for domain were if there's any division and if there's any even roots. So this problem has division, and the issue with division is that we're not allowed to divide by 0. So we want to set the bottom of the fraction equal to 0 and find out when that would occur.
Okay.
And there's no even roots in this one, so we don't have to worry about that.
What would be like the answer?
The 2 things that are in the boxes would be the answer. So that fraction would be the answer of 3 over 2x minus 1. That's our function answer. And then our domain answer would be that x can't be a half.
So then we're finding the domain of just the g of x of just that.
Right. For domain, we're concerned about the domain of the inside, so the g of x, and the final. We don't care about the original outside for domain. Our second example uses the same functions. So I'm still going to have f be my purple function, and I'll have g be my green function. But this time our problem switches the positions of f and g. So at this time, f gets to be the inside function. So to do a composition, you write the outside function, which in this problem is g, except don't write the x and leave a big space. So instead of writing 2x minus 1, I'm going to write 2 space minus 1. And in that space, I'm going to put the inside function. Okay, so that's how we do the composition. Then we just need to do some cleaning. So what do I do with the negative exponent? Turn it into a fraction. So inside of here I can say this is 3 over x. It's just the x that has that exponent, not the 3. If I multiply that by 2, when we multiply fractions, we can think of 2 as being like 2 over 1. We multiply the tops and then multiply the bottom, so I get 6 over x minus 1.
That's our answer?
So that's our function answer. And then we need to think about domain. For domain, we care about the original inside. So in this problem, f was the inside. F has a negative exponent in it, so before we think about domain, we actually want to clean it up a little bit. So instead of saying it's 3x to the negative 1, what should I call it? 3 over x. We'll put that negative exponent down to the denominator. And then we'll think about our 2 questions of domain. So do we have any even roots? Nope, there's no roots in there at all. Do I have any division?
Yes.
Yes. So what can x not be here?
0.
0, because that's what would make us divide by 0. Then we care about the domain of our final. So in our final answer, in the blue box, is there any even root? Nope. Is there any division? What number causes a problem here? What can't we divide by?
Zero.
0. So then that's the same thing as it was before. So then that's just going to be our domain.
So are you supposed to say x can't equal 0?
X
or
can't equal 0.
x is bigger than 0?
Just can't equal. When we're talking about greater thans, that's going to come from having an even root.
So odd exponents or no exponents would cause the x.
Odd exponents or no exponents won't cause any problems in and of themselves. So odd exponents are no problems, and if there's not any exponents, that's no problems. The two problems would be an even root or the division. All right, for this one, we're using the f function twice. We're not using the g function at all. So I'm going to write the f function once in one color, and then I will not deal at all with the g function in this problem and just write another copy of the f function. So I'm going to have an f on the inside, and I'm going to have an f on the outside. We can compose a function with itself. So to do a composition, we write the outside function except leave a blank instead of the variable. So 3 blank to the -1. And in that blank, we put the inside function, which is 3x to the -1. All right, we have a couple of options for how to deal with simplifying this here. I'm going to choose to bring this negative exponent in. You can do that for a multiplication problem. You cannot do that if there was addition or subtraction inside of there. So if it was like 3 plus x to the -1, we cannot do that. But multiplication, we can bring in that exponent and give it to each part. So I'm going to have 3, and then I'll have 3 to the -1, and x to the what? 1. Power to a power, we multiply. So -1 times
Will the
-1
following
makes 1.
students come to the middle school office? Jack.
Okay, so then we have a little bit more cleaning to do. We still have a negative exponent. What do we do with a negative exponent?
Make a fraction.
Bottom.
Flip it to the bottom. So that's going to become a 1 over a 3. And then we have that x to the first, which is really just x. And if I have 3 times a third, I get
1.
just 1. So really our answer ends up just being x. For domain, we want to consider the original inside. So we said on the last problem that we really want to think about 3x to the -1 as being 3 over x. So what domain problem do we have here? X can't be 0. Because if x were 0, we would divide by 0, and that is a problem. Then we want to consider the domain of our final answer. Our final answer was x. So are there any even roots there? Is there any division there? No. So that doesn't have any problems, but we need to accumulate any problems. So we're still going to have our domain be that x can't be 0. Even though our final answer didn't have any problems, the original had problems. Yeah.
How come, like, oh, because you're distributing. Okay, never mind.
In our final example, we're going to compose G with itself. So in this problem, we're not using F at all, and we'll just use 2 copies of G. So to do a composition, we write the outside function, but leave a blank instead of the variable. So instead of 2x minus 1, it's 2 blank minus 1. And in that blank goes the inside function. Then we need to do some cleaning. What do we need to do here to clean this up? Distribute the 2. So I get 4x minus 2 minus 1, which is 4x minus 3. For domain, we care about the original inside. So does g of x have any even roots?
No.
Does it have any division?
No.
No, so its domain is all reals. Does our final answer have any even roots?
No.
Does it have any division?
No.
No, so our domain is all reals. Tonight is the night 2 portion of the assignment.